beautiful question. So here we go. We need to find all natural numbers and belongs to natural numbers such that this inequality holds true. So basically we have to sandwich sine theta between these two windows. Okay, so before we go further, it's better we can play a game here. Let's take n equals 1. So clearly 1 by 4 is less than 0, less than 1 by 3. So clearly 1 by 4 less than 0, less than 1 by 3 is going to be wrong. If I'll keep n equals 2, that indeed will not work, right? If we'll keep n equals 3, so it's sine 60, which is root 3 by 2, is less than 1/3, 1 by 4. If I'll see this inequality, so 2 should be lesser than 4, it should be more than 1 by 4, right? So here again, from this inequality we'll get root 2 lesser than 4, it's fine. From other inequality 3 is less than root 2 is not fine. So like this we can play, but the problem is we don't know values of like sine pi by 11, sine pi by 13 or 17 like this. Moreover, we don't know where to stop. Okay, so that poses a trouble over here. So let's go and see, like, can we sandwich it using graph. So if we'll see the sine theta graph, if we leave from 0 to pi over 2, I'll give reasoning why we are not considering graph in the further part. But before that, what if I join these 2 points? Let's say origin and point P. So that point P on the sine graph is pi by 2 comma 1, right? And clearly sine x will be greater than x. So now I know between these two lines y equal to x and y equals what is the slope? 2 by pi over x, right? This sine x is sandwiched 2x by pi, right? So that gives me some hope, because if I'll take sine pi over n, that will be lesser than pi over n, and it will be greater than 2 by pi into pi over n, provided x is in the window of 0 to pi over 2. So clearly the angle pi by n, since we have already checked like till n equals 4 it's not working. So if n is more than 4, clearly pi over n will be in the window of 0 to pi by 2, right? In fact, it will be lesser than pi by 4 also, but first let's take this window. So using this idea, we got sine pi by n should be sandwiched between pi over n to 2 by n, right? Now according to the question, sine pi by n should be lesser than 1 by 3rd, and it should be more than 1 by 4. Okay, so what we can conclude from here, we know since sine pi over n should be less than 1 by 3rd and sine pi over n is more than 2 by n, so from here we'll get n to be more than 6, right? This is one window I am getting. Similarly, since sine pi over n is more than 1 by 4, but pi over n is more than sine pi by n, so from this inequality I'll get pi over n is more than 1 by 4, and that gives n to be lesser than 4 pi. Now pi is 3.14, so 4 into 3.14 something, so n will be lesser than. Now what exactly is the value of 4 pi? Let's check. 4 pi is going to be 12.56. 12.56, right? So now I know like n has to be sandwiched between 6 to 12, but still this window is not very tight, so we'll try to maybe tighten it up, but at least some hope, because now I have to check for n equal to 7, 8, 9, 10, 11 and 12. So before we go and actually check for all these values, it's better if we can give some tight window. Okay, so for this, let's try at an angle of maybe 30 degree, because 60 degree I'll not try, because we know like after pi by 4, anyway there is no hope, and we have checked pi by 4 is also no hope. Okay, so what if I'll take another angle, let's say a known angle point of 30 degree, pi by 6, comma sine pi by 6, which is half. So what about this loop? This is half over pi by 6, which goes to 6 over pi into 1 by 2, which is 3 by pi. So now the equation of the line given connecting origin to the point A, pi by 6 over 1 by 2, on the sine graph is going to be y equals 3x by pi. So again I can tell sine x will be more than 3x by pi, and so sine pi by n will definitely be more than 3 pi by n times pi. So pi cancel 3 by. And since we know sine pi by n is more than 1 by 4 and is lesser than 1 by 3, so sine pi by n is 1 by 3 is more, right? So that gives, by comparison, 1 by 3 is more than 3 by n, and that gives n should be more than 9, right? And that's the good news, because now we can at least cancel 7 and 8, so there is no hope for 7 and 8, right? So n should be definitely more than 9 as well. I hope this logic is clear. So now still we need to scan through 9, 10, 11 and 12. Now will equality hold for 9? Clearly it's not, because for equality to hold all these three should be equal. So that is not possible over here. So n equals 9 is also rejected, and we are left with 10, 11 and 12. Now we can screen through it, because n equals 10 is a known angle, right? So there is no need to check for 10, 11, because if I can check for known angle 10 and 12, it's sufficient to check for 11, because anyway that is lying between 10 and 12. As you know, sine is an increasing curve. So at 10 if it is coming, and at 12 it's coming, definitely 11 will be somewhere between. 10 means like pi by 10, I mean 12 is pi by 12, so pi by 11 is between this. That will definitely work, right? अब 10 is a standard angle, because sine pi by 10 is already known to you. It's root 5 minus 1 by 4, right? So sine pi over 10 is root 5 minus 1 by 4, and this we can check it in these lies between the interval of 1 by 4 and 1 by 3, right? Similarly, sine pi by 12, this can be calculated very easily, and is root 3 minus 1 by 2 root 2, and this also lies within the window of 1 by 4 to 1 by 3. Hence the final conclusion that I am having is 10 works, 12 work, and since 11 is between them, so 11 will definitely work. Hence the final answer for all values of n is 10, 11, 12. If we were to sum the all values, the answer will be 10 plus 11 plus 12, which goes to 33. Okay, so 33 is the correct answer for this problem. The other way in which you can possibly bond it is using Taylor series as well. So you know, like sin x will be lesser than x, but it will be greater than x minus x cubed by 3 factorial, which is over 6. Okay, and equality will hold at x equal to 0. So यहाँ से भी you can give a bond, like if I'll take sin pi by n, it will be lesser than pi over n, it will be more than pi over n minus pi cube by n cube into 6. So यहाँ से भी bond can be made. Okay, but since it's an algebraic expression, so it will not be that smooth to do from here. That's why I've taken the bond based on this inequality. I hope you have enjoyed the session, and if you want to learn more, keep tuned to my channel.